there are times where you may have to solve the entire triangle, meaning every angle within it. The first thing that you will be able to find, which is the easiest to find, is the measure of the missing angle. So in this case, we're looking for the measure of this angle over here. Well, remember, the sum of the angles of a triangle are 180 degrees. So we know that the right angle is 90 degrees. The other given angle is 52. The only one we're missing is the angle that I labeled theta. But we know that they add up to 180 degrees. So the missing quantity in this case for theta is 38 degrees. Okay. So now we need to solve the entire triangle. So first, I'm going to find the adjacent side. I'm going to label it X. So we have the angle. Now we need the adjacent side. I'm going to use opposite and adjacent, the tangent function. In this case, oh wait, I've mislabeled my triangle. The opposite is X. The adjacent is 35. So 10 of 52 is going to equal X over 35. Multiplying both sides by 35, we'd get that X is equal to 1052 times 35, which is 44.8 units. Now, the only thing left after that is to find the third side. In this case, now you have any number of options. You could use sine, you could use cosine, or you could even use the Pythagorean theorem. So, for example, we know that 44.8, and I haven't rounded it in my calculator, but 44.8 squared plus 35 squared is going to equal the hypotenuse squared. So after I work that out, so I get that C is going to equal, or the hypotenuse is going to equal 44.8 squared plus 35 squared. The square root of that is 56.8. Now you'll know, or one little mental check, you want to make sure that in a right triangle, the longest side is always opposite the longest angle. In this case, in a right triangle, the longest angle is always going to be the right angle. So the hypotenuse should be the longest. In this case, 56.8 is longer than 44.8 and 35. So we know that this is correct. Now, many students will prefer, like we have in the third one, to work in degrees. Their calculator's already in degrees. They're more comfortable with degrees. So they convert pi over 8 and convert it into degrees by multiplying by 180 over pi. What that'll give us is an angle, which is 22.5 degrees. So once again, we know we have 90 degrees plus 22.5 plus a missing angle, which is going to equal 180. Add 90 and 22.5, subtract it from both sides. And you'll find that the missing angle is 67.5 degrees. So we have the missing angle. So now that we have all of that, we can use our ratios once again. Again, we need to find the missing side length, which we will call opposite. The other missing side length is the adjacent. But for this, I'm just going to use the sine ratio because it really does not matter. So for the first one, I'm going to find the opposite. So I have sine of pi over 8, or 22.5 degrees, is equal to the opposite, which I'll call x, over hypotenuse, which is 33.5. Multiply both sides by 33.5, and I get a value for x, which is equal to approximately 12.8. So I have the opposite side. But it doesn't matter in this case. I'm going to use sine again for the next one. So what that means now is that the opposite side is going to change. Now it's over here. The reason why I'm using sine there is because now I'm going to do sine of 67.5. And again, opposite over hypotenuse. Now I'm going to call it y over 33.5. I won't get the same result. 33.5 times sine of 67.5 is going to get me a result, y equaling 30.9 degrees, or 30.9 units in length. Sorry, we're not talking about the angle anymore. So as far as this triangle is concerned, all that I used was the sine ratio. I found the length of the shorter side, which is opposite the given angle, and I found the length of the adjacent side, which is opposite the other angle that we found of 22.5, or sorry, 67.5. And all that I used was the sine ratio. So you could see, you could use Pythagorean theorem. You could not. It's totally your choice.